My sister is a solar engineer, and so and she doesn't talk like the rest of us. I believe at one point she looked out at the sunlight one winter day. It was like February and it was raining, and she said, "Oh my gosh!" She said, "That's about 365 watts per square meter." And I just kind of looked at her. Right, this should be, by the way, an exponent like to the minus two. All right. Okay, so on a winter day, the solar flux is 365 watts per square meter. This is, by the way, I just made that up. All right, what is the total power incident on a roof that measures 12.5 by 45.5 meters and is angled cleverly so it is perpendicular to the sun's rays? Right, it says, in the winter, the sun is way close to the horizon, but this roof is cleverly angled so that these rays of light are coming in. Whoops, I didn't even do it. But imagine that that's a right angle, okay? Because that's what it has to be. And if it's not a right angle, we have to use trigonometry. It's not hard. We just have to do a sine or a cosine or something. Okay, so let's see. What is the power? So intensity is power over area. So therefore, power will be intensity times area. Okay? So there it is, right? So our intensity is 365 watts per square meter. And our area is going to be 12.5 by 45.5. This is my area. All right, so 365 times 12.5 times 45. Whoops. Nothing too tricky here. Wow, that's a lot of power. That's still a lot of power. Okay, so I'm getting 207,593.75. We have only 3 sig figs, so we'd have to say 208 kilowatts, right? Which is the same as 208 times 10 to the third watts, which would be the same as 2.08 times 10 to the fifth watts. But kilowatts is just a commonly used term, so that would be the best way to write it. All right.